Right, so there's two types of compound interest that we're going to talk about. So when you invest money, um, the interest is added onto it, and that's called compounding the interest. And the more often the interest is compounded, you can gain more interest on your interest. And so the more often, the better when you're compounding money. But it's not going to say it's compounded this many times per year. They'll have words that describe the number of times. So for interest that's compounded so many times per year, if it says the interest is compounded annually, how many times do you think that is? If it's annually, one time per year, good. What about semi-annually? Yes. Quarterly? 4. Monthly? 12. Weekly? Yes. And then daily is 365. Now, most of the time, it's these top 4. It's rare that you see weekly or daily in these problems. All right, so what they actually did in this problem is they used this formula. Do you guys remember how much they said he had in his account 1,000 years ago? 93 cents. Good. All right. And then they didn't say this, but the interest, well, they did say the interest was 2 1/4. So as a decimal, that would be 0.0225. They didn't say in the video that it was compounded one time per year. So n would be 1. N is the number of times per year for 1,000 years. I'm going to pull up a calculator real quick. All right, that's where we get the $4.3 billion in his account. All right. Right, so just like all the formulas that we used yesterday, the very first thing after the equation or after the equal sign is the initial amount. So same thing today on the formulas we used today. And we'll just have to figure out the interest rate as a decimal again, figure out what n is, and just plug it in. So I'm going to do a couple that use this formula, and then we'll talk about the other formula. All right, so on example 1, Wendy deposits $550 into a savings account, and the account pays an interest of 4.5% compounded quarterly. All right, so P is going to be this 550. And then just like yesterday, these percentages, we need to change to decimals by moving the decimal point over 2 places. So that's going to be R. And then we said above that when it's compounded quarterly, that n is going to be 4. It's 4 times per year. So I'm going to take this formula. And you might want to put a box around it. I probably should have put a box around it when I made the notes because it's important. You need it. It needs to stand out. But we're going to take that formula in that box and we're just going to plug in all the things that we just found. Now it tells us not to call it A. It tells us to call it W for Wendy, I guess. So we would say that W of T is equal to the initial P. And then just like yesterday with the appreciation, it was always 1 plus. This is also going to be 1 plus, but it's a little more complicated than the appreciation. So we put R over N. So R, we said was 0.045. N is 4. And then we're going to raise it to the NT. So in this case, raise it to the 4T. All right, so that's our function. Now we could, like if we wanted to know after 50 years how much money she would have, we could plug it in. We do want to know how much money Wendy has after 10 years. So we'll just go back and we'll put 10 in for T.
Where'd you get 4T at?
It's in the formula.
Oh, never mind.
You got it? Okay. All right, so after 4 years, her 550 has grown to 860.41. Right. So let's do one more of these, then we'll talk about the other type of compounding. So on example 2, a couple makes an investment of $1,800 into an account that earns 8% interest, which is crazy high, compounded monthly. How much money will they have in 15 years? So P is going to be this investment, the initial investment. R, we're going to take 8% and we're going to change it to a decimal. And like I said yesterday, if you don't see the decimal, it's at the end. And we're going to move it over 2 places. So 0.08. And then monthly, like we said before, that means once a month, which is 12 times a year. Right, then I'll take that P, R, and N and plug it in. Oh, and there's one more thing we can plug in. We can plug in 15 for T. So I'm going to plug all those things. I messed up. Let me go back. Oh, I forgot the 1. Sorry. I forgot what it was.
Not $5,000.
Yeah. All right, I'm just going to start over. I'm not sure what I'm doing wrong.
Got it. Purchase.
What's wrong?
Got it. The first time he did 2 purchases.
Oh, okay. All right, that should be right. All right, now there's another type of compound interest that is called compounding continuously. And one of the days I wasn't here, there was a video in the video kind of explaining what E is. And this is what he was doing. He did it kind of fast. He took this formula and had R be 100%. And then he calculated it for once a year, twice a year, 4 times a year, 12 times a year, weekly, daily, all the way to every second of the year. And what happens is this value gets closer and closer and closer to E. And that was the lesson on E that day.
There's only that many seconds in a year.
That's a lot. Yeah. That's how many seconds are in a year.
30 of it more.
Yeah, 31. There's 525,600 minutes in a year, and then multiply that by 60. It gives you that. Yeah. So anyway, continuously compounded means like constantly it's being added. So that ends up giving you a base of E. So when you see the words continuously compounded, you're going to use a different formula. It's actually an easier formula to use. So put a box around the one that says A equals PE raised to the RT. That's the one you're going to use anytime it says continuously. And that's the same E we talked about that day, Euler's number. Okay, so on the back, we have this problem where Sarah deposits $2,000 in an account that pays 2.7 interest compounded continuously. As soon as you see this, you need to remember that you're going to use the formula that's A equals PE raised to the RT. All right. And on this one, it does tell you, since it's Sarah, they want you to use S of T. All right, so I think we all know that 2,000 is going to be P. And I'm hoping we all know that we move that decimal two places and we get 0.027 for R. And that's all we need to write the formula. So I'll take that 2,000 and put it in for P. E is E, Euler's number. And then we have our R, and then it's multiplied by T. That's the formula. All right, and then if we want to know how much is in her account after 30 years, we'll just put 30 in for T. Do you guys remember how to get E in the calculator? If you need to remember, E raised to a power in the calculator is going to be second, and then Ln. So after 30 years, her money has more than doubled. It's gone from $2,000 to almost $4,500. Now, example 4 is kind of different. Like we're given the formula and we're going to go through and figure out the initial deposit, figure out how many times a year it's compounded, and figure out the interest rate. So it's kind of like working in reverse. And I feel like we're going to be really good at figuring out the initial deposit. Can you guys look at example 4A and know the initial deposit? 200, yeah. The initial deposit is like what's right after the equal sign always. All right, now this one is that compounded interest formula, this one right here. And we need to figure out how many times per year the interest is compounded on that one. And so we can look at what's right in front of the T, and that should tell us that. Let me zoom out a little bit. All right, so this should be N. So that's going to be the number of times per year compounded is going to be 4. Now, the interest rate is a little bit more difficult. So we're going to use what's inside here, but I'm going to take off the 1. So what I'll do on the formula is also take off this 1, all right? So it's going to be R over N is equal to that decimal if we just take the 1 off the front. So I took off both of those 1s. All right, and then we just said that N was 4. Yes, and that's how you solve that for R, is just to multiply by 4. All right, so if I type that in the calculator, you already did it, 0.05? So R is 0.05. No. It's 0.05. Yes, and so that is the interest rate as a decimal. If I want it to be a percent, we move that decimal point back to the right, and it's 5%. Yes, ma'am.
Did you type the R in the calculator?
Right, when I'm doing this part? No, what I did is, okay, I see what you're saying. What I did is I just multiplied by 4, which would cancel out those 4s, and it just leaves you with R. And then over here, I didn't write it. I multiplied that by 4, and it gives you the 0.05.
Okay.
Okay. So if that still feels weird, we're gonna do some more. So don't worry, you're gonna have it. You're gonna get it. So initial deposit. What do y'all think? $1,000. What about the number of times per year compounded? 12. We're just looking at what's right in front of the T. Right, and then this one is the kind of difficult one. So we're going to say that R, I'm going to go ahead and say R over 12 is equal to 0.0025. And we'll do the same thing. We're going to multiply by 12 to cancel it here. Multiply by 12 on that side just to figure out what R is. All right, so what is that as a percent? 3%. All right, let's look at C. For C, initial 400. And then the next is kind of a trick question. If this base is E, it's not so many times per year compounded. So if the base is E, like this one, is continuously. But it makes it way easier to find the interest rate. So this is A equals P E to the RT. So R is just going to be what's in front of the T on this type, which will just be 6%. That's slightly easier than the other one. All right, so we have one more. All right, so the deposit is $6,500. What do you guys think about number of times per year? It's a little tricky. Just once, yeah. So R over 1 is 0.025, which is just what R is. And then if I move that decimal over twice, I get 2.5%. Okay, I'm going to give you your assignment, and I'm going to have you mark out a couple of